Okay, this lesson is over systems of linear equations. And what that means is you have you have two or more equations that are graphed on the same graph, and you're trying to find the point where they intersect. That is the solution, the one solution to both equations. So you can do these by hand, where you graph both equations, fast graph them, and draw the lines and see where the lines intersect. And then we're also going to learn how to do them on the calculator as well. Couple of things I want to point out. If you're given two equations where the slope is different, do you see here in one equation the slope is -1/2, and in this equation the slope is 3? Those are going to intersect, and there's going to be one solution when the slope is different. The lines will intersect. There's one solution. Okay, the solution to these two equations is at this point right there, and the coordinates of that point are at 1, 2, 3, 4, 4, 1, 2, 3, 4, 5, 6, 7, 8. That is the solution, one solution to these two equations. All right, when the slopes are the same, do you see here the slope is the same? The lines are going to be parallel. Now when two lines are parallel, they will never ever intersect. There is no point that will satisfy both of these equations. So when the slopes are the same, there is no solution. Sometimes you might see it written like this, because these two will never intersect. So there is no point of intersection. Okay? And then in some cases you'll have the exact same line. And when the two lines are exactly the same, you've got one line laying on top of the other, there's an infinite number of solutions, because every single point on the line is shared by the other line. So when the equations are the same, there are infinitely many solutions. Okay? So different slopes, one solution. Same slope, no solution. Same line, same equations, infinitely many solutions. Okay? All right. So I am going to fast graph both of these. I'm going to start at the y-intercept, which is at 5. 1, 2, 3, 4, 5. And then from there, I'm going to use my slope, which is 2 over 1. And I'm going to go up 2 and over 1. Up 2 and over 1. I could keep it going in the other direction just to give myself more points. Get my straight edge. Connect these. There's my line. And it's not perfect. Human error will happen. Alright, and then 10 is my y-intercept on the other one. So I'm going to have to, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, oops, right there. Okay, and then from here, I'm going down 3, 1, 2, 3, and over 1. Looks like it's going to cross right there. From here, 1, 2, 3, and over 1. Down 3, 1, 2, 3, and over 1. I can keep going across the graph if I want to. Connect these points. And the two lines are crossing right here. And the coordinates of that point are 1, and then 1, 2, 3, 4, 5, 6, 7. 1, 7. This is my solution. Oops, 1, 7. That is my solution to both graphs. That point is at 1, and then 1, 2, 1, 2, 3, 4, 5, 6, 7. 1, 7 is my solution. Okay. Number 2, same thing. I'm going to graph both lines. For this one, I'm going to start at the -2, which is right there. And then from there, I'm going to go up 3 and over 4. 1, 2, 3, over 4. 1, 2, 3, 4. From here, 1, 2, 3, over 1, 2, 3, 4. Okay. And draw that line. Okay. Now I'm going to graph the other line. It's at -6 is where it starts. So 1, 2, 3, 4, 5, 6. And then from there I'm going to go up 3 and over 2. I'm going to go up 3, 1, 2, 3, and over 2. Up 3, 1, 2, 3, and over 2. Let me see. 1, 2, 3, and over 2. 1, 2, 3, and over 2. I think it's probably supposed to be right there. Let me connect them. Let's see. Okay. And see this, oops, sorry. This is what I'm talking about with human error and why you probably want to do these on the calculator. I'm looking to see where these are definitely going to cross. Let's see. From here, 1, 2, 3, and over 1, 2, 3, 4. 1, 2, 3, and over 1, 2, 3, 4. I'm going to show you how to do it on the calculator so we can check and see what my human error was in making these straight lines. But do you see how important straight edges are? And if you're just trying to hand draw these, even with a straight edge, I'm making some mistakes. So let me show you what we do with our calculator for these. You know, when we had one equation, we used menu 3, 1. Well, now we have two equations. So what do you think we're going to use for two equations? We're going to use menu 3, 2, because we have two equations. So watch, I'm going to go menu, I'm going to go 3 for algebra, and see system of linear equations, 2 for systems. Okay, it's going to ask me how many equations I have. I have 2, and my variables are x and y. So I leave everything the way it is, and I go to OK, and it gives me this weird looking thing. It says linear solve. So in the top box, I'm going to put my entire top equation. I'm going to say y equals 3/4 x. So I'm going to do control divide, and I'm going to put 3/4 x minus 2. Okay? And then I'm going to go down here, and I'm going to put my entire second equation, which is y equals, control divide, 3/2, and then I'm going to do x, and I'm going to do minus 6. And then I've already told it, solve for x and y. It already comes up in your calculator, so you don't have to do any comma x or anything like that. The calculator already does it for you. So I hit enter, and it tells me the point where these two things are going to intersect. So this is a weird one. It does kind of intersect. It looks like it's intersecting somewhere right in there, which is 2 units above, so that's where the 2 comes from. But 16/3 is equal to 5 1/3. So it's saying that I need to go over 1, 2, 3, 4, 5, and then over about 1/3 to get that x value. But I'm going to write my solution is 16/3, comma 2. And I got that from my calculator, menu 3.2. So if it's not intersecting at a nice pretty point, probably be a good idea to do menu 3.2 on your calculator. Okay? But it looks like I graphed it pretty close. Alright, numbers 3 and 4, we can't really do a fast graph because some of the equations aren't in the correct format. Do you see how this one is not y equals mx plus b? Neither is this one. So for these two, we are going to use our calculator. Alright, do you remember the keystrokes for systems? It is menu, 3, and 2 for 2 equations. How many equations? 2. My variables are x and y, and so I'm going to go down and I'm going to say OK. In the top box, I type the entire first equation. I'm going to say y equals, control divide, and I'm going to put -1 on top and 2 on the bottom, and then I'm going to say plus 4. There's the first equation. Oops, that glare. Okay, now I'm going to arrow down, and I'm going to type this next one, which says x minus 3y equals 3. So here's my first equation. See it? There's my second one. It's already got comma xy, so the calculator is going to solve for x and y. I hit enter, and I get this solution. 27/2 and 7/2. So I'm going to say that my solution is 27/2 and 7/2. Now if you're curious of where that would fall on the graph, I would change these to mixed numbers. 27/2 is equal to 13.5, and 7/2 is equal to 3.5. So that means you'd have to go over 13.5 units and up 3.5 units to find the point where this thing will intersect. But you can keep, for answering purposes, you can keep this as your answer. If you had to plot the point, you would probably want to change these into mixed numbers so that you'd better understand how far you're moving left and right and up and down. Alright, number 4, I'm going to use my menu 3.2 because not both of these equations are not in the correct format to do fast graphing. So I'm going to use menu 3.2, 2 equations, x and y, say OK. Top equation is 2x plus 5y equals 10. The bottom equation is y equals 2/5, excuse me, 2 over 5 x minus 3. And I'm going to hit enter, and it gives me this solution. So my solution is at 5 over 2 and negative 4. So this point of intersection I think will actually fit on the graph. This is 2.5, comma negative 4. So the point of intersection would be if I went over 2.5 units and down to the negative 4, it'd be right there. These two lines would be intersecting at that point right there. Okay? If we were to graph both of them. And that's it. That's systems of equations. You can either graph them, but remember there's human error that could be involved, or you can always use menu 3-2 on your calculator. It will tell you the points of intersection.